All right, we're going to look at 3.4, finding the slope of lines. Slope of a non-vertical line is the ratio of the vertical change, rise to run. Rise vertical, run horizontal, between any 2 points on the line. Negative slope falls from left to right, such as line J. Positive slope rises from the left towards the right, such as line K. A zero slope is a horizontal line, such as line L. And a vertical line, such as line N, runs up and down. Postulate 17, slopes of parallel lines. In a coordinate plane, two non-vertical lines are parallel if and only if they have the same slope. Any two vertical lines are also parallel. Postulate 18, slopes of perpendicular lines in a coordinate plane, two non-vertical lines are perpendicular if and only if, when you multiply their slopes together, you get -1. Okay? We also call that the opposite reciprocal. Okay, so for example, if I tell you a slope of a line is 3, and I want to know what the perpendicular slope for a line that would be perpendicular to it, its slope would be -1/3. Parallel slopes are the same. Perpendicular lines are the negative reciprocal. So you flip it over, you change the sign from negative to positive or positive to negative.
So
Want to try one more?
Yes.
Wait, what if the slope is -1/2? Give me something perpendicular. The perpendicular slope. Not -2 would be
2 over 1.
yeah, or 2 over 1.
So it's
Okay.
contrapositive.
Wait, so it's always the bottom number?
It's just flipped.
But if it's negative at the beginning,
It becomes positive. If it's positive, it's becoming negative. So you switch the sign. Excuse me. Shh. You make it a fraction. So for example, 3 would be 3 over 1. You flip it. That's how I got 1 over 3. And if it's positive, it's negative. If it's negative, it's positive.
So basically,
Okay.
we're just multiplying by the reciprocal, the negative reciprocal.
And what is that?
That is when lines are perpendicular, their slopes are opposite reciprocals. Which is just what we talked about.
We're trying to comprehend it.
It is the slope of perpendicular lines. Yes.
Could you explain the postulates again? I don't really understand them.
Postulates are flat out rules. You can't prove. They're just there. Okay. Theorems you can prove using postulates and other things.
One up, one, two.
Okay. Let's look at example 1. Okay. So we're going to find these slopes and be able to tell if they're parallel, perpendicular, or neither. Okay. So I'm going to use 2 lines. Do you guys remember this? To find the slope, you do y2 minus y1 over x2 minus x1. Yeah? Okay, so I'm going to look at A. We've got 0.6, 4 and 0.8, 2. So I'm going to label it x1, y1, x2, y2. So that's 2 minus 4 over 8 minus 6. So I get -2. 8 minus 6 gives me 2. So that gives me a -1. Okay, so now I'm going to figure out B. B's points are 6, 4, because they both go through the same point right here, and 4, 0. So I'm labeling them x1, y1, x2, y2. So I go 0 minus 4 over 4 minus 6. So I get -4. 4 minus 6 gives me -2, so I get 4 divided by 2 is 2. So are they parallel, perpendicular? Are those lines parallel or perpendicular to each other, or neither? Neither. And they're on the same plane, so we can't call them skew. Yes, Nathan, who raised his hand. Hold on.
How do you know if they're perpendicular?
Parallel have the same slope. Perpendicular have the opposite reciprocal.
So if one was like -1/2 and the other one was 2.
Yes, that would be perpendicular. Yes, go ahead.
Did you guys go over this in chapter 1?
No, this was algebra 1. Algebra 1, we talked all about slopes.
Yeah.
Okay, so let's look at example 2.
Is that where we counted over and we counted up? And then
Yeah.
rise overrun?
Yeah.
Okay.
Yes. All right, so we are going to figure out the slopes for these 3 lines and figure out which ones might be parallel to each other. Do you guys want to see it the graphic way?
Yeah.
Okay, so if we're at 1, 2, 3, 0, and we go up 1, 2, 3, over 1, then my slope is 4 over 1.
4.
Okay?
So we don't have to
Just
do-
4.
we don't have to do the line.
Sometimes you'll have to do it one way, sometimes you'll have to do the other. So you need to know both ways.
So it's rise over run.
Yes. The next one we start at 3, we go up 1, 2, 3, 4. Okay.
4.
And we go over 1, so we get 4 over 1. And then the next one is, we're at -5, and we go up 1, 2, excuse me, we're at -2. Go up 1, 2, 3, 4, 5 over 1. So which ones are parallel or perpendicular to each other?
K and K2.
K is parallel to K2. And you know that because they have the same slopes. Okay, now we're going to talk about if I give you 2 points and then ask you to make a line perpendicular to them. Okay, so we're going to look at this. First thing I'm going to do is draw in my X and Y axes.
Is the homework going to be this simple?
Should be. Okay,
It should be.
so we're going to go 3, 0, and then we're going to go 7, 3, 4, 5, 6, 7, up, 1, 2, 3, 4, 5, 6. So here's one line, and I want to figure out how to graph the line 1, 2, 3, 4, 5 that goes through this point but is perpendicular to that line. So I know I've got to find the slope and then find the negative reciprocal. So first I'm going to find the slope. Do you want to do it graphically or algebraically? Graphically?
Seems way simple.
Okay, you go up 1, 2, 3, 4, 5, 6. And you go over 1, 2, 3, 4. So it's 6 over 4, which reduces to
3 over 2.
3 over 2. So I know if I want to make a line that's perpendicular to it, what would the perpendicular slope be? -2 over 3. Okay? So then I go back to this red dot, and I'm going to go down 2 over 1, 2, 3. Down 2, and over 3, or up 2 over 3. And we've got a new line that meets it at a 90-degree angle.
Alright,
You did.
where's the 2.5?
Okay, so I'm going to go over it again.
Thank you.
So I plotted the 2 points, and I found the slope from them. The slope from them is 3 over 2. If you want a perpendicular line, it has to be the negative reciprocal. So I found the reciprocal, which is 2 over 3, and it's positive, so my new slope is negative. We good there? Yeah? So then I went to my dot, and I just followed the slope. I went down 2, over 3, down 2, over 3. We good?
Is that the only,
Wait,
I don't know, how do you, it's all, if we do it like that,
Yeah.
it's always going to be positive, like when we do,
Well, not necessarily. If the line was going in a different direction. If it was going this way, you'd know it'd be negative. This way, it's positive. So,
oh,
the red one, I know I go down 2 over 3.
because it's like this, because it,
Yeah.
and this means positive.
Yeah. If it looks like, if you go to the left-hand side and it looks like you can walk up it, it's positive. If it
Okay.
looks like you have to walk down it, it's negative.
Okay.
Okay, Brooks, so what?
Yes, Fran.
Did you get the red one?
Okay, so I found the perpendicular slope, right? And then I went to the dot 2, 5, and I just went down 2 over 3, down 2 over 3.
So it
You
kind of,
gotta find the slope first.
Yes.
it depends on the question. too?
Yes.
Okay.
Jacob?
How do you get -2 over 3?
Okay. 3 over 2 I got from the blue line, right? I went up 6 over 4, which reduces to 3 over 2. So that's the slope. And then when it's perpendicular, you have to flip it and change it from positive to negative or negative to positive. Does that help? Okay. All right, and now we've got an activity instead of writing.
Yay, Joyce, sort of.